Welcome back to Arxflix. Today, we'll dive into the research paper titled Global Context Networks. This paper reevaluates the widely known non-local network, NET, and proposes an alternative called the Global Context, GC, block, offering the same accuracy with significantly reduced computation. The main observation in this study is that the global contexts modeled by NET are almost identical across different query positions. This inspired the authors to create a simplified, lightweight network that retains NET's accuracy. Let's get into the details. NET captures long-range dependencies through a self-attention mechanism. Each query position calculates pairwise relationships to other positions, forming an attention map. Features are aggregated using this map, then added to each query position. However, empirical analysis showed that these attention maps are nearly the same for different query positions. Check out this heat map, almost identical attention maps across the board. Based on this redundancy, the authors propose a simplified block. Instead of computing query-specific attention maps, a single query-independent attention map is used for all positions, drastically reducing computational load. They also replace the one-layer transformation function of the non-local block with a two-layer bottleneck, further reducing the parameter count. This redesigned block is called the Global Context, GC, block. It follows a three-step process. Firstly, context modeling to form a global context feature. Secondly, feature transformation for channel-wise interdependencies. And lastly, feature fusion to merge the context into all positions. With its lightweight computation, the GC block can be embedded in multiple layers, unlike NET, which is usually limited to fewer layers due to its processing demands. This leads to the development of the Global Context Network, GNE. The equation illustrates the simplified non-local formulation used in the GC block. On benchmark tasks like COCO for object detection and segmentation, image, not for image classification, and kinetics for action recognition, GNE outperforms NET with minimal increase in computation cost. Here's another example. GNE, achieving significant gains on each of these tasks, demonstrates its robustness and efficiency. In object detection and segmentation on COCO, GNE beats NET by 1.9% on AP text box and 1.5% on AP text mask with just a 0.07% increase in flops. For image classification on ImageNet, GNE yields a 0.8% improvement in top 1 accuracy, and in action recognition on kinetics, it shows a 1.1% gain in accuracy. While adding GC blocks to all layers improves performance, the most substantial gains come from higher layers, reflecting better semantic feature integration. The Global Context block proves effective by capturing long-range dependencies with reduced computations, making it suitable for various recognition tasks. The simplified approach of using a query-independent attention map marks a significant step forward in efficient network design. That wraps up our overview of global context networks. Check out the full paper for more in-depth analysis and data. And as always, don't forget to like, share, and subscribe to Arxflix for more research paper breakdowns. See you next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.